Today's lesson covers section 6.3 in the text, covering complex fractions. We'll begin by defining a complex fraction. We can think of a complex fraction in two ways. It's either viewed as a fraction divided by a fraction, or another form of a complex fraction is when we have a fraction within a fraction. So let's look at some examples of each of these. In the first example, we have a complex fraction which consists of a fraction divided by a fraction. And we are charged with the task of simplifying this complex fraction. So the first method that we're going to use to do this is where you change it from a division problem into a multiplication problem. So recall that we can rewrite a division problem as the numerator. Instead of division, we do multiplication. So it's the numerator times the reciprocal of the denominator. So instead of 6x squared over 9, I'm going to multiply by 9 over 6x squared. And then at this point, we just are multiplying two fractions, rational expressions, and we have covered that last week. So what we need to look here is for common factors that can cancel out in both the numerator and the denominator. For instance, I see that the 9 and the 27 can both be divided by 9. The 2 and the 6 can both be divided by 2. And one of the x's cancels out of the numerator, and one of the x's cancels out of the denominator, which means we are left with 1 times 1 in the numerator, and 3 times y squared times 3 times x in the denominator, which gives me 9xy squared. In example 2, we also have a complex fraction which consists of a fraction divided by a fraction. So I'm going to use the same method. I'm going to rewrite it as a multiplication problem. The numerator times the reciprocal of the denominator. Look for common factors. The only thing I can see that I'll be able to cancel out here is the 5 and the 10 can both be divided by 5, leaving me with 1 here and 2 here. So in my numerator, I'm going to have x times x minus 2, and in the denominator, I'm going to have 2 times x plus 2. I don't see any common factors between the numerator and the denominator, so that's my final answer. In step 3, we're going to look at two different methods for this one, because now I have fractions within a fraction. So the first method I'm going to use is similar to what I did in the last two examples. But before I can change this to a multiplication problem, I need to change it to a single fraction over a single fraction, which requires me to find the lowest common denominator in the numerator and the denominator in order to combine into a single fraction. So in the numerator, I have an LCD of y squared, and in the denominator, I have an LCD of x squared, which means that this fraction needs to be multiplied by x over x to find the common denominator, and this fraction needs to be multiplied by y over y. So let's combine that. My numerator is going to have a common denominator of y squared, and the numerator will be x plus y. And in the denominator, my first term remains as y, second term becomes x, and my common denominator is x squared. Now once I have this changed to a fraction divided by a fraction, I can use that method of changing it to multiplication. So I do the numerator times the reciprocal of the denominator, looking for factors that cancel. I see that x plus y and y plus x are the same. Those cancel out, and I'm left with x squared over y squared. Another method we're going to look at is called the LCD method. The LCD method allows you to clear the fractions, and it's very helpful. when you have complicated fractions within fractions to get rid of the fractions in the first step. The way you do this is you look at all your denominators and you find an LCD for all four of these. So my LCD is going to be x squared, y squared. Then I'm going to multiply the entire numerator by the LCD and the entire denominator by the same LCD. And the way we look at this is I need to distribute that LCD to both of those terms and to both of the terms in the denominator. All right, so what happens here is when I multiply x squared, y squared times x over y squared, you can see that the y squareds will cancel out. So you're left with x squared times x, which leaves you with x cubed. The denominator goes away. That's why we call this clearing the fractions. In the second term, x squared, y squared times 1 over y, one of the y's will cancel out. So the denominator goes away, and you're left with x squared y. The two terms in the denominator, when I multiply x squared, y squared times y over x squared, the x squareds will cancel, leaving you with y squared times y. Y squared times y is y cubed. And then x squared, y squared times 1 over x, one of the x's will cancel, leaving you with xy squared. So now you look back and think, well, this is the same problem. They should have the same answer. Don't forget that you should factor to see if you can simplify anything here. So in the numerator, I can factor out a GCF of x squared, leaving me with x plus y. In the denominator, I can factor out a GCF of y squared, leaving me with y plus x. And now I see that these terms, x plus y and y plus x, those two factors are the same and they cancel. And it leaves you with the same answer we got in the last example using method 1, x squared over y squared. Okay, I'd like to end with giving you 3 examples for you to try on your own. So copy these 3 problems down and then pause the video and solve them on your own. From this point forward, I'm going to start solving each of them. So after you've solved them, then restart the video and you can check your answers. All right, so let's look at that first example there. Here I have fractions within fractions. I'm going to use the LCD method, which allows me to clear the fractions. So my LCD for this one is going to be a squared, b squared. So I'm going to multiply the numerator by a squared, b squared. And I'm going to multiply the denominator by a squared, b squared. Distributing. In the first fraction, one of the a's is going to cancel. So I'm left with 5ab squared. And in the second fraction, both a's will cancel. So I'm left with b squared times b, which is b cubed. Over, in the denominator, when I multiply by the first term, the b squareds cancel, and I'm left with a squared times 5a, which is 5a cubed. And when I multiply by the second fraction, one of the b's cancel, so I'm left with a squared b times 1. Okay, then I factor to see if I can cancel anything. In the numerator, I have a GCF of b squared. Factoring that out leaves me with 5a plus b. In the denominator, I have a GCF of a squared. Again, leaving me with 5a plus b. The 5a's plus b's cancel. And my final answer is b squared over a squared. In example 2, I'm going to use that same method, LCD method. My LCD is going to be x, because the only denominators I have are x in both the numerator and the denominator. So I'm going to multiply x times the numerator, x times the denominator, and then distribute. X times 2 is 2x, plus x times 1 over x. The denominator cancels, the fraction cancels, and I'm left with just 1 over x times 4x is 4x squared, minus x times 1 over x is 1. And then I notice that this denominator is a difference of squares, so I can factor that, 2x plus 1 times 2x minus 1, and then the 2x plus 1 factors cancel from the numerator and the denominator, leaving me with 1 over 2x minus 1. And for the last problem, I need to rewrite this as fractions. Keep in mind that here only the a is being raised to the negative 1, so the 2 stays in the numerator and the a moves to the denominator and the exponent becomes positive 1. Plus, same thing here, only the b is being raised to negative 2, so I move that to the denominator and the exponent becomes positive 2. Over 1 over a to the positive 1 minus 1 over b to the positive 1. Now I have fractions within fractions. My LCD is going to be a, because I've got a's here, and I've got a b squared. So I'm going to multiply by ab squared times both the numerator and the denominator in order to clear the fractions. Distributing, when I distribute the ab squared to the first term, the a's cancel, leaving me with 2 times b squared, plus when I multiply times the second term, the b squareds cancel, leaving me with 3 times a, over, same thing in the denominator, when I multiply by the first term, the a cancels, and I'm left with b squared. When I minus, when I multiply by the second term, one of the b's cancel, leaving me with 1 times ab. Now I see that I can factor in the denominator, but not in the numerator. So I could factor out a b, leaving me with b minus a. But that doesn't help me to cancel anything. So that means that either one of these answers would be acceptable for a final answer. You don't have to show both forms. That's it for today. Have a good one.